Hi guys, Mrs. Delisin here. Welcome to another lesson of AP Statistics. Today's lesson is learning about power. And we are going to interpret the power of a significance test and describe what factors affect the power of a test. What is a power of a test? That seems to be a new word for us, right? Power. So let's start. Recall that Mrs. Gallas claims that she's an 80% free throw shooter. Mr. Wilcox is skeptical and believes that she is a less than 80% free throw shooter. Mrs. Gallas has decided to take another SRS of 50 free throws to prove herself. So let us write our hypothesis and define our parameter. We always have to start by defining our parameter so we know what we're trying to get. So in here, we're trying to get the true proportion of, let me say, FT, the true proportion of free throws made by Mrs. G. There you go. True proportion of free throws made by Mrs. G. Because she's claiming she's an 80% shooter. Is she really gonna get 80% of the 50 free throws that she's making? We don't know. We'll see. So our null hypothesis, we believe Mrs. Gallas. We believe the claim. She's an 80% shooter. Our alternative hypothesis is we don't believe her. She is not an 80% shooter, but less than 80% shooter. So that we don't have a hard time when we are asked to do a type 1 and type 2 error, I usually suggest putting words onto your null and your alternative, because just a number, sometimes it's confusing, yeah? So this is Mrs. G. Mrs. Gallas is truthful. Mrs. Gallas is telling the truth that she's an 80% shooter. In here, Mrs. G, should I put liar? Liar is kind of like a really harsh word. Let's just say exaggerating. She's exaggerating that she's not really an 80% shooter. Okay. Describe a type 2 error in this setting. Do you guys remember what type 2 error is? Type 2 error is the alternative is true, but then we failed to reject the null. Meaning, the alternative is true, but then we believe the null instead. Okay? Or, in other words, Mrs. G is exaggerating, but then we didn't find a convincing evidence that she is. So, what is that in context? Mrs. G is less than an 80% shooter. Oh, let's do free throw shooter. But we failed to reject the null. Okay, we failed to reject the null. We didn't find a convincing evidence against it. Suppose Mrs. Gallas' true free throw percentage is actually 66%. HA is true. Enter all the information into the applet. Click the display type 2 error. It will show as a blue shaded region. So I am going to answer this one together because if I keep coming back, when I switch from the website to my notes, I have to reload the website at all time. So I am going to just do A and B together and I will just write it later. Okay, let's read it first. If HA is true, what is the probability of a type 2 error? Remember, type 2 error is a bad decision. Okay, bad decision. Even if HA is true, we didn't find convincing evidence for it. If HA is true, letter B, what would be the probability of making a good decision? Meaning, the HA is true and we're actually finding evidence for it. Okay, and then C, interpret the probability of this good decision in context of the problem. So let's go to the website and hopefully it will load. So here's what I'm saying, every time I go out and then go back, it will not, I have to reload it. Okay, let's change our null hypothesis. It's not 0.33, it's 0.80. Let us change our alternative hypothesis to less than 80%. click or check the box for type 2 error. The true value of P is not 0.5, yeah, it's 0.66. Oh, okay, there you go. The sample size is 50. Type 1 error is the alpha level, so the alpha level is 5%. I wasn't told what alpha level to use, but I'm assuming it's gotta be 5% because I wasn't told. Okay, the blue region that you see right now, right? The blue region is what we call the type 2 error. So the type 2 error on the top is 24%. You see guys, this one right here. So the blue region is 24%. Type 1 error is the 5%. And we already know that. What do you think that power is? That's 76%. Power is 76%. So if I say the blue region here, to the left of the blue region is what we call the power. That is what the 76% is. That is the probability of making a good decision. So in this case, the probability of making a good decision is better or is higher than the probability of making a bad decision, which is good, right? We want a good decision, not a bad decision. Okay, so let's take a look. The null is 0.8. The null is 0.8 right here, the red one. It is overlapping the blue region, yeah? It overlaps the blue region because the whole entire red is the null, and then the whole entire blue curve, that is for our alternative. So this blue region is overlapping to our null hypothesis, right? It overlaps the type 2 error. That's why it's a type 2 error, because sometimes even if HA is true, we said that HA is false and we believe the null hypothesis. That's the type 2 error. All right, so let's go back to the paper and let us, if HA is true, what's the probability of type 2 error? That's 24%. This is type 2 error. And then, I don't know how to spell error. There you go. And then if HA is true, what would the probability of making a good decision? 76%. That is your power of a test. If you add the power and the type 2 error, that's 100%, right? Okay, just making sure. Interpret the probability of this good decision. So again, probability of making a good decision is the power. So let's interpret that. If Mrs. G is a 66%, the true proportion, free throw shooter, there is a 0.76 probability that we decide correctly, or we make a good decision, that she was exaggerating, or that she is a less than 80% shooter. We are going to reject the null. So our power in here is that if the alternative hypothesis is true, we make a good decision of rejecting the null. Okay, now let's go to the next one. And I want to, do you notice a conditional probability going here? So the power is rejecting the null given that HA is true. So okay, there you go. Click display power. We want to increase the power of our test. How could we adjust each of the following factors to increase our power? Use the applet to explore each. So if we increase the sample size, what happens to the power? If we decrease the alpha, what happens to the power? If we decrease the alternative, what happens to the power? Okay, we want to increase the power. Okay, so let's see. How do we increase the power? All right. Oh, see, that's what I was saying. Every time I go log out and go back in, it disconnects and I have to redo it again. So we'll answer all the questions all at once so that we don't have to. I'm going to click the box for power, okay? Oh, there it is. My true value is 0.66 at the moment. There. My sample size is 50. My alpha is 0.5. 0.05 I meant. So the blue region is the type 2 error, making bad decision. Our green region is the power of a test, making a good decision. Okay. How do we increase the power? Do we increase or decrease the sample size? So we want the green region to be more than the blue. So let's change what if we increase the n to 200? Oh, the blue is no longer there. The type 2 error is now 0%. So and the power is 100%. So when we increase the sample, the power increase. So increase sample, power increase. Good. So let's put that back to 50. Because when we decrease the sample, look, the blue region is more than the green. We don't want that one. We don't want that the blue is bigger, because that's bad. Okay. How do we increase the power by moving the alpha? So what if we have bigger alpha, let's say 0.10? Oh, when we increase the alpha, the power increases. But if we decrease the alpha, let's say 1%, or 0.07, if we decrease the alpha to 2.5%, the power decreases. So we don't want to decrease the alpha, we want to increase the alpha for our power to go up. What about the proportion? Right now, our proportion is 0.66. Further from 0.80, right? So if we increase the alpha, if we want to increase the power, do we also increase the proportion? So do we go closer to 0.8? Oh, no, we don't. Because as we get closer to 0.8, the type 2 error gets bigger, and we don't want that. So in order for us to increase the power, we have to limit the overlapping, because when the null and the p, the alternative, overlaps, that means the type 2 error increases. So we don't want to overlapping, we want it further. We want the p further, the sample proportion further from the null, so that our power increases. Okay, back to 0.66. There you go. All right. So we wanna decrease the proportion, right? Or technically, we want to make it further away from the null. We want the proportion, the true value of p, to be further away from the null. Okay, let us fill it in. For the sample size, in order for us to increase the power, we have to increase sample. We want to increase sample size, because increasing sample size decreases variability, and we know that already. For alpha level, we want to increase alpha in order for us to increase the power, because it makes it easier to reject HO. Okay. Alternative, we had to decrease, in this case, we had to decrease the P. We have to decrease the P means increased distance from null. Okay. That's it, you guys. Let's do our important idea section. Oh, let's draw let's draw the table. And then remember, like, there is it has to be there. So this is my 0.80, my null. This is 0.66. And then remember the power, this overlapping blue region here is my type 2 error. And then this whole, let's actually color that green. This whole entire area is our power. It should be green, yeah. That is our power. Okay. And then this whole entire thing is, of course, our null. And this line is a cutoff. Is a cutoff to reject HO. Okay. Hoping that wasn't that confusing. We are going to remember that I made a table for you guys before. I'm gonna make a table again. Oop. I'm the best drawer of squares. It's not even a square. But that's not important. What's important is what we're writing. Okay. Oh. Let's do this one. And divided that there. So we have HO is true. Remember this? HA is true. A reject HO. Fail to reject HO. So if HO is true and we rejected HO, okay, hold on. Okay, HO is true but we rejected HO. This is type 1 error. HA is true but we rejected HO. That is power. And then this one is HO is true and then we fail to reject HO. That is a good decision. And then this one is a type 2 error. HA is true but we failed to reject HO. Okay. And what else did we learn? The probability of type 1 error is the alpha. The probability of type 2 error is 1 minus power. Or the other one around, power is 1 minus type 2 error. And then we've also learned how to interpret power. Right? How do we interpret power? If HA is true, specific value in context, whatever that is, and in my case that was in the case that we had earlier, that was 66%. So if HA is true, there is a, whatever your power is, probability of finding convincing evidence to reject a null, whatever the null is in context. Okay, is that it? What else did we learn? We've learned, oh, how about increasing power? Where do we put that? Let's put that over here, right? So to increase power, we don't have space. To increase power, we increase sample, we increase alpha, and we increase the distance from null. When I say increase distance from null, I'm not saying to increase the proportion, because sometimes to increase the proportion, sometimes we have to decrease the proportion away from the null, or sometimes we have to increase the proportion away from the null, depending on which side you're going. If you're going to depending on the alternative hypothesis. Okay? Because let's say, for example, if my proportion, my null, my claim is that 80%, and then my alternative is less than 80%. So for my power to increase, I need to go further away to the left of 0.80. Okay? So if I want it the other way around, if my alternative hypothesis is my null is 80%, and then my alternative is greater than 80%, to increase the power, I have to go further away from the null, to the right of the null. Okay, I'm hoping that was not that bad. A statistic major and a finance major decide to get married. In order to investigate their per-person expenses, they select a random sample guest they have invited to the wedding and records whether or not each person plans to attend the wedding. They decide to test HOP equals 0.75. That means 75% will attend the wedding. And then our alternative is not equal to 75% because they're unsure if it's more than 75% will attend or less than, right? The true purport, or P equals the true proportion of all guests that will attend the wedding. The power of the test to reject the null, P equals 0.75. When P, this is the true. Okay, wait, let me highlight that first. True value of P. And then alpha of 0.05 and of 0.25 is 0.10. So power is 0.10. Okay. Now we are going to interpret this value. So we are interpreting the power, which is 0.10. So if the true proportion, of guests that, too much writing, yeah, that will attend the wedding is 0.70, there is a 0.10, that's the power, probability that they find convincing evidence to, this power is really small, to reject the null. And the null is, to reject the null, which is, what's the null? Proportion of guests is 0.75. Okay. So how do we increase the power in here? Because it's really low, 0.10. We only have a 10% of making a good decision. So to increase the power, we want to decrease this 0.75. We want to decrease the 0.70, or we want to increase the 0.70, right? We want to increase the distance of the true value from the null, from the 75%, in order for our power to go up. Or we can increase the number of sample, which is 25. We can increase that. So find the probability of type 2 error. Of course, probability of type 2 error is the alpha itself. The probability of type 2 error is 1 minus power. So 1 minus 0.10 is 0.90. Oh my goodness. The probability of making a bad decision is 90%. Determine whether each of the following changes would increase or decrease the power of the test. So right now, we are using 0.05 5 or 5% for our alpha. What if we lower that? What if we lower the alpha level? If we lower that, the power would even decrease. The power would decrease. We don't want to do that. The power would decrease because the alpha level decrease. Which makes it harder. Which makes it harder to reject the null. You won't be able to reject the null. Because your p-value is now, you're now looking for a p-value that is lower than 1% in order for you to reject the null. And that's kind of hard to do now. So what if we increase the sample from 25 to 100? So if you do that, the power would increase. Because of course, lower variability. All right, there you have it. I hope that this lesson is going to help you, and I'm going to help you to do your homework, and you are now able to identify what is a power and to interpret power. And please remember, power is the probability of making a good decision. That when we're supposed to reject a null, we actually rejected the null. Okay? Thank you guys, and I hope you are going to be able to be successful in doing your homework on this one. Thank you. I'll see you guys on the next video. Bye.